Okay, so resultant force. So the first thing I'm going to talk about is Newton's first law and his second. So Newton's first law was that a body will remain at rest or at a constant speed unless acted on by a net resultant force. Okay, so either remain at rest or at a constant speed unless it's acted on by a resultant force. That's the first law. And I'll go into a bit more detail about what does that actually mean. So I've got a ball. It's on the ground. It's got weight of 50 newtons. Now, if it's got weight of 50 newtons, then it's also going to have an upward force. This upward force of 50 newtons is known as the reaction force. And this force here is weight. So in this example so far, I've got 50 up, 50 down. So that's 50 minus 50 equals 0. So that means that the resultant force equals 0. So my ball's not moving, and everyone's pretty happy that my ball's not moving. Okay? Now let's say I have the same ball, 50 up, 50 down, but this time I give it a kick of 150 newtons. Okay? Now you can see that these two cancel out, but there's nothing to cancel this one out. So now I know that it is going to speed up in the direction of the 150 newtons. I know that it's going to get faster in that direction. Okay. Now let's imagine a rocket in space. And you fired off from the Earth and you're travelling at a speed of 1,000 meters per second. Okay? You're travelling really fast. They then turn off the engines. So no more engines. What speed are you travelling at? Well, you're still travelling at 1,000 meters per second because nothing has made you slow down yet. Okay, so you get up to a speed of 1,000 meters per second, you turn your engines off, then you will carry on gliding at that speed of 1,000 meters per second until something makes you slow down. Okay, and that's the bit that people forget. They think that things will slow down on their own. They won't. They need a force to make them slow down. Let's get back to my ball situation then. So if I've got my ball, I've got 50 up, I've got 50 down. You've kicked it, so you've given it a speed of 15 meters per second. Okay. You've no longer got a forward force because you're not kicking it anymore. The ball's now just going along the ground. But it does have a force going in this direction. And that would be your friction. So and friction always goes in the opposite direction to which you're moving, okay? So if you've got 15 meters per second in that direction, then you know that the friction is going to be acting in this direction, and that is what is making it slow down. So this will make it slow down in the direction of the friction. Okay, so it was going at 15 meters per second, but the friction slowing down, so it's going to decrease. This one, it was traveling 1,000 meters per second. You switch off the engines, but there's now nothing acting on it at all. So there's nothing going to make it slow down. It's going to continue at 1,000 meters per second. And that is Newton's first law. Okay, something will remain at rest, which was this ball, or at a constant speed, which was this rocket, unless acted on by a net resultant force. In this example, the resultant force was 150, which meant it get kicked in that direction, speed up to 15 meters per second, for example, and then it would slow down because now the resultant force is the friction going this way, and it'll slow down until it's back to zero again, because when the speed is zero again, the friction will be zero again.